Now in this video we'll be learning about vertical motion under gravity. Under this topic we make a very important assumption, that is the air resistance is negligible. Because of this, the acceleration is always a constant. We use the letter g, and the value of g is equal to 9.8 meters per square second, and for these of calculations we use the value 10 meters per square second. Since we assume that the air resistance is negligible, the only unbalanced force acting on the object is the weight of the object. Therefore, the acceleration acting on the object is independent of its mass. For this, let's say there is an object of mass m and the weight will be mg falling under gravity. Let's say the acceleration is equal to a. If we apply F equals ma downwards, the unbalanced force is mg and the mass is m and the acceleration is a. Therefore, we can get the acceleration is equal to g. Therefore, the acceleration is independent of the mass of the object. Now let's move on to a question. Find the time taken for a ball thrown vertically upwards with a speed of 20 meters per second from the top of a tower of height 60 meters to reach the ground. The object is projected vertically upwards. So we can apply the equation s equals ut plus half at square. In the downward direction, the displacement is 60 and the velocity is minus 20 into time. Let's say the time is 10. The gravitational acceleration always acts downwards, that is 10 meters per square second, and therefore we will get a quadratic equation, and then we can divide this by 5. Now if we divide it by 5, we get the equation 12 is equal to minus 40 plus t square, and then we can solve this using completing square method. Since time is a positive value, it is plus 4 plus 2, then time will get the answer 6 seconds. So the ball will take 6 seconds to reach from A to D. Now here the object A is vertically projected with a velocity of 30 meters per second, and after 4 seconds the object B is dropped from the same level, and then we have to find the distance or the depth from the edge of the wall to the place of collision. Let's start by applying s equals ut plus half at square to A in the downward direction. S is the displacement, therefore let's say the displacement is x and the initial velocity is 30, and since we are applying it down in the downward direction, it should be minus 30, and the time taken, let's say it is t, and then half acceleration is 10 and t square. Then we get the equation x is equal to minus 30t plus 5t square. That will be our first equation, and then let's apply s equals ut plus half at square to B in the downwards direction. The displacement will be x and the initial velocity will be 0, and the time taken will be t minus 4, and the acceleration is 10 and t minus 4 square. Then we will get the equation x is equal to 5 t minus 4 whole thing square. That will be our second equation. In order to solve this, let's equate the first equation and the second equation. Then we get minus 30t plus 5t square is equal to 5. Let's expand this term. We get t square minus 8t plus 16. And then if we simplify this, we will get this equation. And then 5t is in both sides, so you can cancel them off. And then if we simplify, we get t is equal to 8 seconds. Therefore, the depth, we took it as x. So from the second equation, x is equal to 5. Let's substitute t as 8. 8 minus 4 square. Then we get 4 square. 5 into 16. X is equal to 80 meters. Therefore, depth of the collision level from the edge is 80 meters.